Call it out.
What's the matter? Did I call you out?
On my test, and it's fighting words.
Up the game next time. That's all it takes.
Maybe I'll just sit here.
Mike? All right, guys. Any questions from the quiz, maybe?
Why? That was the question.
That was my question too. Sometimes.
Why?
Why? So whenever I ask you to find a few other points, you should probably do that, and make sure your scale makes sense. Don't say 1, 2, 3, 4, 5, and then 12 is right there. That doesn't make the most sense. So you have to pick a good scale. I'm not forcing you to use 5 by 5. You can use whatever the hell you want to. I just happen to give you 5 tick marks. What else can I say in general? I think a few of you just haven't done the synthetic division section yet. Or actually, hopefully not. Because it didn't seem like you understood synthetic division at all. It's really powerful, it's good to know, and you need to know it. I think otherwise, there wasn't anything specific that I can say. Any questions from the quiz? Yes? Oh, how do you find the y-intercept? Or?
Yeah, you just test points on that on the very last one.
So actually, on number 3b, I ask you to find find the intercepts. So when I say that, I mean x and y. And the really cool thing is, it's given to you in number 2 in non-factored form, and that's the easiest one to use for a y-intercept. Because you just make x 0, so the y-intercept is just the constant term.
For x, you plug in like 0 on the left, and then you solve for.
Yeah. And then you solve, and then you see what y is. Cool.
One more question, like the question in the first one, like the square root of cube 3x plus 1. Like this wasn't in the book. Like I couldn't find out, so I couldn't practice on this question. Like finding it. Was it inverse? Yeah, inverse of x.
So section 2.7.
No, like there were questions about it, but they were like, in other words, they were not like there wasn't any question about the cube root of square root or like cube square.
I don't care.
Yeah.
Just to be completely rude, I don't care. If you have a square root, you have to square to get rid of it. If I have a cube root, I have to cube to get rid of it. So it's.
So like, what could be the step in order to get rid of the cube root? Cube it.
So you said you did ones with square roots in them, right?
Yeah.
Yeah. So if you had. How would you find the inverse for this?
Y equals to x minus 2.
And then switch the x and y. And we solve for y, right? And right here, what would you do?
Just change the y to x.
Well, don't change it back again. Solve for y, so then you do what? How do you solve for y? Square both sides. Right? And then keep going. So if it was a cube root here instead, what would you do to both sides?
Cubing on both sides.
Cube both sides.
Yeah. I think that's what I did.
Good. Well, you should know. You got your quiz back. So yeah.
It's like still confusing.
Yeah. And do what now? So if your function starts off as 2x cubed, let's say negative plus, right? And then you factor it somewhere, that doesn't change fundamentally what the function is. If I have this, let's just say, what's the highest power on x? Yeah, 3. The highest power on x is 3. If I wrote it out, it would come out to be, so it's a cubish, and it's negative cubish, right? So it should do what a cubish normally does, except reversed. Yeah.
Yeah, that's what I put.
Cool.
Then you minus 4 points.
Totally did. Because did you put like a little too much in there or something?
After, but I guess.
Ah, no. Don't do that to me. Yeah. Otherwise, I'm like, how the hell did you know that? You see what I'm saying? You're not supposed to know that yet. Gotcha. Okay. So be real careful, like I said. It was really obvious, and in fact, very often I took off more points than you might think you need, but you should know that if you're the person who did it in the calculator and copied it onto your paper, this is very often very easy for me to tell. So you will lose a decent amount of points if you do that, especially on a test. So I better see where your work feeds into your graph. If you can't see where your work is wrong and the graph you're getting is not the same one you see on the calculator, I don't care. Stick with what your work says your picture should look like. And then say, it didn't look the same in the calculator, I'm not sure what I did wrong. You will get more points for that than somebody who does the work and then just copies out of the calculator. That's pure crap. I have to make sure you understand how to do the work and then how does it translate into the visual. And if you just take the visual from the calculator, you're not translating it from what you did to the graph. That's not, I can't test what I need to test then. So be real careful. I can especially tell when it's copied from the calculator when I see stuff like this. I mean, I love that. Where you just, I mean, what the hell's that mean? You just didn't change your window enough so you can see it, and you're like, all right, well, that's what it says. It must be right. Come on now. Okay. Yeah, some weird ass stuff.
You don't get points for trying.
If you put something down, if I didn't take 12 points off, you got points. Sometimes I'll take 11. You got a point. We're doing something, but you didn't do anywhere near what I needed you to. Any other questions from the quiz? Okay, any questions from homework? Yeah.
35, 3.3.
It's 12.
So this one here, right? This one here? Yeah. So where'd you have trouble? What's the...
The synthetic comes out weird. Like you get a 0 in like the middle of the synthetic.
That's fine.
And
What would go in the penalty box for this?
1/2.
Yeah, positive 1/2. What goes here?
2, 3, minus
Negative 2
plus
and
1.
1.
Good, because I'm not missing anybody, right?
Right.
How'd you know one happened? Oh, never mind.
3 down.
So now the 2 comes down. 1/2 of 2 is 1. Good job. 4. 1/2 of 4. Now here's that 0. I like that. Here's that 0 you were talking about, right? You get a 0 right there, but who cares? Keep going. 1/2 of 0. 0. So how would you write this then?
2x squared plus 4x
Plus 1.
Plus 1 over x minus 1/2. Yeah, I like that. Whoever said that. Cool. So there's your remainder. And there's what it goes into, how many times it goes in. Cool.
Oh, just so you know, if you do the computer homework and you don't put the parentheses around that, you get it wrong at the bottom of the remainder.
Oh, if you don't put that?
Yes,
All right.
thank you. Now I can breathe.
But of course, it's limited by not having this long bar. When you have the long bar, you don't need the parentheses. If you don't have the long bar, you need the parentheses, yeah.
You do on the computer program.
See, now that's why I don't make WebAssign mandatory. Because it's really easy to get frustrated when it doesn't accept the right answer because you don't have the right format. You know that personally. I don't want to deal with that times 50.
That's why they give you 3 tries so you can get the formatting right. You're like, okay.
Pretty much for the formatting, yeah. All right, guys, any other questions from homework? Yeah. Oh, you got one? I'll go. Let's see. One really nice thing about this, and the instructions say find the real zeros, use the quadratic formula if you need to. One really nice thing about this is what's the list of possible rational zeros?
2 and 1.
2
Possible rational.
minus 2 and 1.
All right, too many words.
2 minus
I'll
1.
do Dan Quayle's.
1 negative.
Plus or minus 1 and 2. Right, that's cool because this is a 1, so it's not going to bring any fractions in when you make the ratio. And 2's only got those. You only have 4 possible rational zeros.
Yeah.
So hope to God that 2 of these go in. If 2 of these go in, what degree will I be left with? Squared.
Score.
If one goes in, that's cubed. If another one goes in, that's squared. And then I can use quadratic to clean it up at the end. Right? So did you get one to go in? Who asked that question? Did you get one to go in? No. Shit. So I don't know. Let's take a look at 1. Yeah, it looks like that's going to work actually, dude. Sorry. So if you do 1, 1, 3, 3, 1, 1, negative 2, negative 2, 0. So that goes in. And then hopefully something else has to go in also.
Negative 2?
And I like the fact, I think I did this once, but I like the fact some of you guys caught on, so you just kind of keep going now. 1 could go in again. You can't cross it off your list. 1 could go in again. And we can try it again real quick. 1, 1, 4, 5. No, it's not going to work. You can kind of tell, hopefully, kind of quickly if it's going to work or not. If I try negative 1, I don't know. No, that doesn't look like it's going to work. Cool? And so forth. And then I can try, what do you say, negative 2?
Yeah.
Yeah, cool. And then this guy is going to need quadratic to finish it out, right? So far, what do I have? This equals x minus 1, x plus 2.
X squared minus x plus.
X squared plus x minus 1, cool. And then that last piece, you got to use quadratic. Quadratic. It's writing too much already. Yes?
While we're on this assignment, I couldn't do 100 or 102. Well, not that couldn't do it. Well, yeah, I could do it.
So we got this here. All right, 100.
What number was this?
100.
Oh, they already done this for you. Crappy. Thank you. Okay.
Question number? Question number?
100, yeah. And notice they got a little picture of a calculator there, so they're trying to tell you you might eventually need a calculator cell. It might come out in pre-calculus if it's not quadratic. If it's not a quadratic function, we cannot find like a max or a min. This was just asking what are the dimensions of the land, so we'll see what we end up with. Maybe it's something funky, because what are we missing to be able to really do this problem?
Side.
Yeah, like this side, right? Like a width. So how can you get that? Pythagorean theorem. So we'll say this side we don't know, so we'll call it 1. Yeah, so x squared plus y squared is x plus 10 squared. This is where people will say that this is x squared plus 100, which of course you're screwed from the beginning. So be real careful. This happens often enough. You gotta remember, don't forget that middle term here. So then y squared equals, you'll get x squared plus 20x plus 100 minus x squared. Is that cool? And then, so y equals plus or minus, but of course we know it's a length, it's a width. So it can't be the negative, it's got to be the positive. Okay, cool. I like that. So you know you've got to use Pythagorean, because you know you're missing this side to really connect with what they tell you. They tell me what the area is, but they don't give me the right stuff to set up an area equation. So I have to first, okay, what is it that I'm missing? I'm missing this side. Now I got it. So what's the area? Area is 5,000 square feet, and that equals what equation? X times this thing. So now you just got to use a calculator. The way to do this, I don't know if you guys remember, any equation that you have, you can set one side y1 and the other side y2. And then see where they meet. Of course, this is going to be a flat line. You just got to see where it meets the square root function. And that'll be what x is. If they ask you for what y is, or what, I think they ask you for the dimensions, so of course you just got to figure out what y is on top of that. You guys sort of with me?
What y is on top of that?
You got to figure out what y is along with that. All right, maybe. Did everybody follow me along with this here? Okay, this reasoning, just setting up the Pythagorean, I can solve for the side I don't know, and I can use now what they told me. I can make the equation that goes along with it. And now that I've got to solve this, and this is why they said they have the little graphing calculator picture next to it, because now I'm allowed to just using graphing calculator to solve it. It's the only time I can do that. Because if I try to solve this by hand, what would I do first? Be careful now, I don't know how you mean. You can't distribute the x through a radical because you can only multiply things that have like radicals. So maybe a good first step would be to kill the radical, because that's the thing that's in my way. Square both sides. So you get 2, 5, 0, 0, 0. X squared times this. So you get this, there's no way in hell I'm going to factor that. Right? And it's probably not got a nice answer. So that's why this is a problem where they have the graphic calculator on it, so you can use that. Don't forget, I mean, anytime they have that picture, you can use it. And if it's asking you to solve for something, that means you can throw one side into y1, the other side into y2, and see where they meet. That's the basic idea. How to use a graphing calculator to solve an equation. Are you guys cool with that? Yes, sir. Okay. You got this here? Any of you guys watch Community at all? You know that show? I can't get it out of my head now. When I say Farrah, you say pissed. Pissed. You guys remember that scene if you watch it? You see the last one? I'm just killing time while this takes it. Yes, sir.
Now what's the percentage for the homework?
Do it again.
What's the percentage for the homework?
Oh, how much is the homework work? It's part of the homework quiz average grade, so that's, if I remember correctly, 20% on the syllabus.
20 or 25?
20 or 25, yeah.
So,
So what? I know what you're asking, and I'm not going to say it. Alright, so if you want to graph this, remember y1 was 5,000, y2 was x, somebody help me out, square root of 20, x,
X times square root of 20, x plus 1 quarter.
thank you. Now, obviously, I'm not even going to try to graph this directly because this first one's way up the hell at 5,000. So I want to at least go to window and change my y max, and say to 6,000. Maybe make my x max, I don't know, 50 or something. I have no idea. Let's see if that works. All right, I see that. I knew I'd see that.
Ooh.
Ah, see now?
Uh-oh.
So they're going to meet somewhere.
Somewhere.
So I want my x max to maybe be, I don't know, let's make it 200. Do you guys see my reasoning when I'm doing this?
Yes.
I knew it was going to meet. I didn't see far enough, so I want to see further over, so I make x max bigger. Now I see the intersect.
Uh-huh.
How do you use this?
Second. Count.
You hit enter, Jeff. Remember the shortcut to this?
Second.
Put it on the center. Yeah.
Put it right on the answer. Enter. It bounces to the second line. Enter, and then it asks you your guess, and we're already there. Enter. There's a freebie. Be really careful. Is this your answer? Now, I just happen to call that with Y. This is not the answer for that. If the area of that is 5,000 and the width is 5,000, this has got to be 1 then. That's the only way that's not true. So this is not the Y that I need. I've got to plug this X value back into that equation
You better use the 0.08.
for Y. Say again?
You better use that 0.08 or you're not going to get a good answer. If you just round it off to 106, you're not going to get a good answer.
Yeah, 106.08 at least. Yeah, cool. I like it. Is that good?
So what does the number represent?
Yeah, this represents what that X value has to be.
The one side.
Yeah. What this has to be is this. That's perfect. That's nice. All right. If this has to be this, so this has to be, of course, 116.08. Now I just got to figure out what that has to be. Just plug that X value in here. Cool.
Oh, math.
Okay. You guys with me a little bit?
Sort of.
You guys see the point I make about I chose Y as a variable here? That does not mean it suddenly is every Y you guys see everywhere. That's the Y for the output for this equation. And of course the output is 5,000 because that's what we want the area to be. You've got to plug X in here to figure out what your width is. Okay. So maybe never call it Y, maybe call it H or W. Yes, sir?
So this is probably a dumb question, but why does the intersection of the line of the area and the function show the X value?
When I find where this meets this, the X value at that point must be the answer. That's what makes this equal this. If I find where two lines meet, that X value is what makes those two lines equal. So I'm trying to say, when is this equal to that? So finding their intersection is the equivalent. Cool. That happens a lot in mathematics, where you have a problem in one form, and you translate it maybe visually, or you translate it into a different coordinate system or something, and you do the problem there, and then you bring it back. Just because it's easier. So this is easier to do visually, especially because we have these graphing calculators that can do this stuff visually, quickly. Yes, sir.
Can we also do 102? I just suck at these problems that look easy but aren't.
Oh, okay.
Yeah.
So we got this here.
Did we do the volume of the box?
All right, it's the last one I'll do. Then we'll get to a review of that 3.7.
I need it because I don't think I did this one. He's doing it. Because he's doing it.
Because like this is
Please don't put this on a test.
All right, so the basic idea is to cut these corners out so that you can fold these in and make that shape. Right? So this is open, if you can tell. Yeah, I know. That's right. Thank you for humoring me. What's this here?
Side. X.
Yeah, that's X. Is that cool? Because when you fold that up, it's going to be that tall. Everywhere it's going to be that tall when you fold it up. Are you with me? So you have to have a little spatial reasoning on these kind of problems. X, what's this going to be here? That's basically this.
20 minus 2x.
Yeah, 20 minus 2x's. I like it. There's x, so 20 minus 2x. So equivalently, this is going to be 40 minus 2x. And now you just set up the volume formula, right? They tell you the volume is supposed to be this. So of course the volume, algebraically the volume will be what?
Density of
that.
Don't.
That times the X.
Stop.
Okay, so it's
You must use the ideal gas law. No.
Oh,
He started. So 1500.
because the volume is 1500.
Now this one does not have a little calculator next to it.
That's unfortunate.
I know.
Well, surprise. In my house, there's a calculator next to it.
I like that. You're drawing them in. All right, so now you just got to multiply this side out. You can't set each piece equal to 1500, right? No. It only works when this is 0.
Yeah, so even
So
make
you
it
just
0.
have to suck it up and let's see, this will be 800x minus 80 minus 40 minus 120 x squared plus 4x cubed, and multiply everything by an x as I go through there. So it looks like I could divide everything by 4. That's useful. So subtracting that over, dividing by 4. What's that going to be? 25 less than 4, so 375. Is that right?
Yeah.
Thank you. Equals 0. Now it sounds like they're claiming that this actually factors, so
Okay.
I at least got you here.
Looks like it
Now
passed.
you need to get the rest of the way. But you guys, very often they'll tell you something directly, and then it's got to relate to all these unknowns. So I mean, you just figure out, okay, they told me the volume. I need to get a volume formula eventually. Do I have everything I need to get the volume formula together? Yes, I do. So that from the picture equals that they told me. So what's probably going to happen from this is you might get one complex answer and two real, or you might get one negative answer and two positive answers. Because they told you there's two specific ways to do this. Maybe something will be a multiplicity of two. Some way you're going to get one answer here that's bogus.
How would you try to get an answer?
What method do we have currently that would help us do this? Synthetic, yeah.
Oh, synthetic division.
You have a couple of good things here. Now, I want you to realize something. X cannot be larger than 10, for one thing. How do I know that? Probably because of what I just pointed to, right? If X is bigger than 10, then this, in fact, if X equals 10, or is bigger, this side is 0 or negative. Well, that's neat. So X must be less than 10. If it says X is less than 20, that's even better. X has got to be less than 10. Right, so that really limits the stuff that you have to try here. You with me? You don't have to use Descartes. You don't have to use any of that stuff. You don't have to use lower upper. You just use physical reality. Did not know I needed that for the math. So that hopefully will help.
I don't think anything's going to help this one.
Okay? So give that a try on your own time. Any other questions? I think I said that was the last one. Anyway, good. All right. So I want to do a review of section 3.7. And then we're just going to get as far into chapter 4 as we can. Yes? Oh, up through, well, as far as we get through today. Yeah. Starts at 2.7. So the test that, I'm not sure if you all saw that last time I put up on the board. It's not this Wednesday. It's next Monday. So the test is on Monday. It's going to cover as far as we get through today. So some of you guys are saying, how can we stall him? But that's a bad idea because then it's going to make the next test loaded down with more stuff. You gotta be careful. Keep that in mind. All right, so let me break down 3.7 a little bit. All I want you to do for these next few problems I'm going to put up here is to find those asymptotes, right? So when I write va, that's vertical asymptote. Ha is horizontal asymptote. Va. Va. Ha. Okay. Let's see now.
5 words. What section are we in right now? 3.7? Okay, so first we have to factor in. We knew this one. The horizontal asymptote is 1/2. This one is 1/x, which is undefined, so it's 9. And this one it's
Factor the denominator.
0. Because it's x
Good first step.
over is x, y is x. That's what I got that. And the vertical asymptote.
So whenever I do this, this is no quiz. So if you want to look in the book, you look at your notes.
I gotta find. So,
Ask the person sitting next to you.
need some help? Comes from the domain, back to the domain. So let's factor in the domain, we get negative 24 factors to negative 5, 6,
These are the same, so this, and that, and then zero.
quadratic. Do you know how to do this? Did you factor that one already? Did you factor that? 8 and 3? 8 and 3. Negative 8 and positive 3. Oh, yay! X minus 8, x plus 3. So the vertical asymptotes are 8 and 3. 8, 0, 8, 0, 8. X equals 8 and x equals 3. And on this one, the horizontal asymptote is y equals 1 half.
8
Because-
and 2. Oh, 96 goes with 8.
As x squared over 2
You don't have
x
to do
squared
that.
goes to 0, it goes
Take
to
a
a really
200.
big number, goes to
Oh,
infinity,
You talking about this one still?
it turns into
Take a
a
2 out.
1 half.
2 and x out.
Take a 2. You can't take an x out.
Okay.
48 and a half.
And this one, when you factor it, you get what? X to the cube. 8 and negative 3. Yeah.
That should be
This one, you factor it and you get what?
X plus 16 minus 16. So the vertical is
X plus 5 over x times x squared minus 16, which is factorable, to x plus 5 over x times x plus 4, x minus 4. So x equals 4, and x equals minus 4, and there's no horizontal asymptote because as x over x cubed goes to infinity, 1 over x squared goes, as 1 gets really big, x squared gets really small. So there's no horizontal asymptote.
So I didn't ask for any x-intercepts, but a good first step is always just factor everything. The x-intercepts would come from where if I asked for them? The top. The only way to make a fraction equal 0, which is what you have to do when you want to find the x-intercepts, is if the top is 0. Didn't ask for that. Cool. So don't have to worry about it. So what tells me the vertical asymptotes?
The bottom.
The bottom, because the bottom involves figuring out what values of x are not allowed to be used. Does that make sense? That's why we put those real walls there. Can't go here. So the vertical asymptotes here would be x equal 8, x equal negative 3.
Oh, you have to change this answer.
Be very careful. You must write them as equations of lines. If you just put 8 and negative 3, that doesn't mean a damn thing to me. What situation am I in for the hop?
1 half.
Yeah, looking back here, the factored form does not help you out for the hop. You want to look back here. The powers are the same. So then the horizontal asymptote would be the
Coefficient.
ratio of the coefficients of the highest degree term, right? So in this case, it'll be 1/2. Y equal 1/2. Real quick, I know we all completely hate, well, I don't know, I could actually leave that blank on the left unlimited, you guys can fill in it. But we certainly hate long division. But what would be the first step here? 2x squared goes into x squared how many times?
1/2.
1/2. Isn't that what? See, so the funny thing is this, and I'll give you a little clue, this, they could both be looked at for the ha as the same first step, you long divide. Here, though, is there a horizontal asymptote? It turns out that it's going to be a
0. It's going to be slant.
slant asymptote. Cool. So we'll get there in a second. So that's all I asked for there. Which means when I put a really large x value in here, in fact, let's try that out.
1 million X's.
All right, cool. So I can get away with this. So here's some kind of cool. Let me put this down here. Three of them in here. So that first expression. Here's some kind of cool. Let me show you something that's going to get you through some parts of calculus, for example. You're not going to go to calculus, so 1/2. Let me say this again. I want to go. Yeah. The larger x gets, the closer you get to 1/2. So it'll give you a value you want to plug in for x to kind of investigate that 1. Now what's the idea of the horizontal asymptote? You let x get
300.
really big, so 300 sounds good. And 1 is relatively big relative to 0.00001. So now watch this, it's kind of cool. If I do 300 stored in x, see a little stow button?
Stove.
A little stow it away. Store 300 in x. Now this is kind of cool. I can then just put the expression in directly. Somebody help me out. It was x squared
Minus 1.
minus 1 divided by
2x squared minus 10x
Whoa.
minus 48.
Because now x on this screen, not my graphs. Don't worry about messing your graphs up. Whenever you do graphing, it understands x to be whatever the hell it needs to be. But on the screen, x will always be 300 now. So if I do that, I get something really damn close to 1/2, don't I?
Wow.
Now here's something really cool. So if I make, let's make x
1 million.
300,000 store in x. Now here's a really cool thing. Hit second enter. Second enter. So I don't have to put all that crap in there again. Now I'm even closer to 1/2, right? You do this kind of thing a lot in the first 2 weeks of calculus. If you're not going to go into calculus, oh well. But you do this kind of thing, you get closer and closer to something you're not allowed to be there, so you just get as close as you can to it, and you observe patterns. Well, if we do this, you can see it's obviously going to 1/2. That's what saying y equals 1/2 is a horizontal asymptote. That's what that means. As x gets really, really big, the outputs approach 1/2. They never get there. That's the idea of an asymptote. Or sometimes they might get there. Who cares? They just have to get really, really closer to that value. Cool. Okay.
That's pretty cool.
There. What about this guy here? What's the vertical asymptotes?
X plus 4.
4, negative 4.
4, negative 4, and 0. Good. There should be 3 vertical asymptotes, unless there's some complex roots. If there are complex zeros here, They're not going to be on a real plane graph. But they're all three real zeros, but are all three be there. What situation am I in for the horizontal asymptote?
Is 0.
Yeah, the bottom one is a higher degree than the top, so the whole thing goes to 0. The bottom gets bigger quicker. It dominates the whole expression. The whole thing gets small. So it goes to 0.
If it's smaller, then we're going to be putting y equals to 1 over v.
Say again?
If it's smaller, the value of the denominator is smaller, then we're going to be putting y.
Like 3?
Yeah, like the stuff.
If the bottom power is smaller than the top power, it goes to infinity. Because the top now grows quicker than the bottom. The bottom can't keep it in check. These first two, the bottom kept it in check. The bottom grew just as fast as the top did. So it kind of balanced out to 1/2. Here, the bottom grows faster than the top. The whole thing goes to 0. There, the bottom can't keep up with the top. The whole thing goes to infinity, but it does so in a very prescribed manner.
Along with x.
So first off, what's the vertical asymptotes here?
The vertical asymptote is -3 and 3.
3 and -3. I like it. The horizontal, no. So the slant,
The slant is you have to divide.
you have to divide.
Comes out to be x minus 4.
So if you do that, x cubed minus 9x, change the signs. -4x squared plus 9 minus 4.
No remainder.
Change the signs. Who cares about that? The big deal is that. All right, the remainder goes away when x gets really big. So it's got to go to x minus 4 when x gets really big.
If it's a slant, do we need to write it down as slant, or could it be horizontal asymptote is x or y equals x minus 4? Does it matter? Doesn't matter.
No, it's not that it doesn't matter. Don't do that.
Once we're done.
Because this is not a horizontal asymptote simply because it's not horizontal.
Slant.
Yeah. So don't call it that.
Don't label it HA.
You can do like that. None of these, but a slant. We have a slant asymptote.
Y
Cool.
equals x minus 4. It's
There is no
whatever you-
ceiling, but it does get to grow following this line eventually. That's the idea.
So that's your slope. That's y equals x plus b. That's
Yes, sir.
We're going to be doing the long division only when we have
y equals mx
infinity.
plus b.
When you have a slant, when you have a top power higher than the bottom, top degree higher than the bottom degree, yeah. Yeah.
If is it possible to do synthetic if the bottom is of the right degree?
Sure. Yeah. You can do synthetic. Okay. In fact, I could use synthetic on this, believe it or not. What am I dividing by really? I'm dividing by x minus 3 and x plus 3. So I divide first by 3, and then whatever I get left over, I divide that by -3. Put that in the penalty box. So as long as this thing is factorable, and everything's factorable, but they don't always come up to numbers that I want to use. This could be irrational. This could be complex. I don't necessarily want to do synthetic with 3 plus I root 11. So thank you. Okay, cool. So you want to do, let's do one example all the way out, and then we're going to get into chapter 4. All right. Seeing very little reaction to that, we'll do that.
Luckily, in this
So we got this here?
So
Are you doing the last?
You're going to give us our pretest on Wednesday, right?
Actually, no, I got it today.
yeah,
I'll give you the answer key on Wednesday.
Yeah, and then you make it slant to pick any point. Yeah, and instead of making it forward, gotta go by one.
So then we got one from 3.7. Anybody started 3.7 homework yet?
I did it.
And we got one that's giving you a lot of trouble, or you want me just to pick one out?
Yeah, do number 50 because I'm not sure about the domain.
I heard number 50 first. Sorry, buddy.
Okay. That sounds great.
That's a lot of work
Oh, this shit.
going on.
Yeah, taking normal stuff and making the word doubles.
Okay.
a hard one.
So basically on a test or a quiz, I would put these steps down. I would say, or at least I'd say it in a sense, I'd say find the intercepts, the asymptotes, a few points, whatever. I'll kind of tell you what all I need to see done. So how do I find the intercepts? What's the y-intercept?
2.
I love it. Because to find the y-intercept, you just make x0, negative 4 divided by negative 2 is 2. What about the x-intercepts for x-intercept?
Well, you have to like factor it.
Good, right? We said earlier the x-intercept must come from where? The top, because the only way a fraction can be 0 is if the top is 0. So you might as well go ahead and factor this stuff. How do you factor the bottom?
Negative 1 and 2.
Plus 2 minus 1.
Yeah, plus 2 minus 1. Cool. So what's the x-intercept?
2, 0.
Yeah, 2, 0. How are we doing so far? That shouldn't be the hard part yet. What situation am I in for? Well, let's do. Well, what's the vertical asymptote? Let's get that right off of what we got.
Well, it's negative 2 and 1. X equals
1, negative
Yeah.
2.
Whatever makes the bottom 0, I've got to exclude those values. That's exactly what vertical asymptotes mean. They are walls saying you cannot go here. So x equals 1, x equals negative 2. Cool. And what situation am I in for this?
y is 0.
Yeah, the bottom degree is higher than the top, so the whole thing is going to get really small and go to 0. In fact, long division helps you out here too. I know we all don't like it, but x squared goes into 2x, no times really. I mean, it's a remainder itself. So that's 0, just like the other part would be. Okay. So now for my artists out there, you can set up your chicken wire or your foundation or your structure, whatever the hell you want to look at it as. I'm going to put the walls up and put some anchors down as to where my graph is. So I got the walls here at 1. And negative 2. Horizontal asymptote is the x-axis. My y-intercept 0, 2. I'm not sure what my scale here is going to be yet. Let's just be a little conservative. Let's not put that on there yet. My x-intercept is 2, 0. So I have very little information here. The fact that my y-intercept is up here somewhere tells me that my graph has got to be, how does it have to be shaped? Like this, like this.
Like a U.
Yeah, it's not allowed to go through here, not because there's an asymptote there, because it's going to go through right there. Why is it not allowed to go through here?
You don't have any.
Because I don't have any doors. There's the only door is there. Nowhere else can it go through the x-axis. So be real careful. Some of you guys drew it going through the x-axis, and you had put your x-intercepts down, and then it somehow went through somewhere else too. I don't know how that happened. It can only go through the x-intercepts. So the fact that my y-intercept's up here is going to tell me it's here. But let me get a feel for what kind of scale I need. How do I figure out what's going on over here?
You have to plot some points.
Plug something in. So what's f of negative 3, for example? It'll be twice negative 5
Negative 3.
over negative 4 times negative 1. So it looks to be 10/4 negative 5 halves.
5 over 2.
Yeah, so negative 2.5. So then I can use this scale, looks like. So at negative 3, it's at negative 2.5. All right there, so it's going to be doing this kind of thing. You guys with me so far? So I'm hoping you guys start to realize visually it's got these regions. You want to figure out what's it doing in each region, and you have all these kind of hints as to what the hell it's doing. Here I know it's got to be something like this. You know, I could get one more, I could figure out what f of negative 1 is, to see if it dips down and comes back up through there. What is f of negative 1? Twice negative 3, negative 2 times 1. So it's 3?
Yeah.
So it looks maybe it's probably going like this. In fact, I would rather you make the mistake. Maybe it kind of goes lower here and starts to go back up later. I don't want to see that on your graph if your work doesn't tell you that. Obviously, then you copied it from the calculator. I don't want these to be perfect. They should be imperfect because you're trying to get them just from what you've done. There's no way right now that you have the math to get all those kind of like little, where is the smallest part? You can't get that. I don't want to see it. Now over here, let's see who understands what's going on here. This is a first degree. So what's it going to do at that root? It's going to go through, right? If it was an even power, it would turn. So the weird part is it could either go shoot up, but then what's it got to do?
It's got to come back down.
It's got to come back down eventually, or it can shoot down through and then it's got to come back up eventually. Either way, it's got to come back towards the asymptote there. So I got a couple things I could do. All I really need is to put in line like f of 3. Let's see what f of 3 is. Put a 3 in there, I get 2 over 2 times 5, so I get 2/10, 1/5. So can somebody tell me that's all I need? Why is that all I need? Because I know it's got to start where? Down here or up there? It's got to start down here because it's going to go through. That's the only way we could possibly get back to that point. So it's got to start down here, through, and then it's going to hug the thing there. And that's good enough for what we can do mathematically right now. Now, if you do it in the calculator, you're going to see a few more details that we can't capture by hand. I'm cool with that.
But it wants the domains and the range.
Okay. Domain we know already when we found the va. Right? My vertical asymptotes are here and here, so what's my domain?
X.
Everything else? So it's
Negative infinity to negative 2.
like that, right? Skip negative 2, skip 1. What's my range? The range is going to be kind of freaky. And they want to know the range?
Yeah.
2 negatives, positive and negative 2.
Oh, okay. Well, our best guess for the range. The range is definitely starts at negative infinity, and it goes up to what?
0.
It goes a little bit above 0, doesn't it? It goes up at least 1/5. Probably goes up higher. Somewhere probably goes up higher and is coming back down. It's most likely that's not the peak. But again, by hand, that's the best I could do.
2/9.
So the range is at least from negative infinity up to 1/5. And where does it start over again?
2.
The best I can say right now is 2
Positive and
to infinity. Cool. Now, using a graphing calculator, you could find the minimum here, you could find the maximum there, you can get a very precise answer. That's nice for it. It's much more important, as you're learning this stuff, to be able to do it to a point by hand. You can only do it to a point yet. Yeah.
So do we only look at the range of the right? Like, why didn't we look at the range?
Because this guy's lower than that guy. That's why. They both start at negative infinity. This guy only goes up to 0 because he doesn't get through there. So that's why I only have to worry about this guy to see how much he pushed it up. Yeah. Cool. So you guys understand that if you wanted the exact range, you could use that maximum function in the calculator. It's more than likely not 0.2. All right. How do you feel about that? This is a very good example about compartmentalizing what you're doing. You know how to get intercepts. Don't forget any of them. You know how to get the vertical asymptotes. It's all about factoring those. So if you have trouble with that, you should be focusing on that. You know